Hey folks, this is just a quick internal training primarily related to the Pentair Environmental Systems Goyen valve particulate monitor demo that we received. I've got that all set up and ready for field use. I'll give you a brief overview. Some of you, I already discussed this with you. Pentair is the parent company. Goyen was owned by Tyco, now by Pentair. Another division that's available to us is the Gager pulse valves and controllers. The reason PCME is up here is because Goyen stopped manufacturing particulate monitors. And then they went to the factory in England of PCME, which is owned by a competitor company, and negotiated such incredible pricing direct from the factory that we can now be competitive almost anywhere in the country. We will get 15 to 45% depending on quantity and competition. All this technology is related to reverse pulse cleaning systems, and that is filtration units as well as tremendous bag houses where there's hundreds and hundreds of valves and hundreds of particulate monitors. And essentially what it does is it's either a time cycle for the ID fan is sucking dirty air or gas into the filters, and then at a time sequence depending on how quickly they build up with particulates, these valves fire like an air cannon the opposite direction of the flow to knock that dust or particulates off into a bin or a hopper or a conveyor. Some of that is waste intended for a landfill, and some of it is product. So they're both important to the manufacturers who need that technology. We also have timers and controllers related to that cleaning cycle, whether it's smart based on differential pressure or it's just a time cycle and they clean them whether they're dirty or not. Okay. The three basic sensors, excuse me, there's the sensor alone, which is just a loop-powered 4 to 20 milliamp electromagnetic sensor electronics with a rod that's inserted into the process on the clean side, preferably. And the whole point of this is if the clean side stops being clean, they want to be notified before they're dumping product or waste into the atmosphere. Okay? The demo that we have is called, the model is called the FFA, and the reason I requested that is because it's standalone. You don't need a PLC to look at the data, you don't need a power supply, it's all encompassed. So it has an operator interface, and I'll show you that in a bit. It has the sensor. Now there's one step above the FFA, because the FFA is really not designed for networking. It's not unlike a FireEye product where they have relays to tell you when you have a problem or whether you can light the flame. There's two programmable relays on the FFA as well as a 4 to 20 milliamp output if they want to take that signal back to a control room or something. The next step up is networkable with software. So you could have like 50 sensors, bring them back to your control room, and then connect them up with the software for large systems. What you're going to find out in the real world is 90% of our customers have just the sensor. And that's simply because it's less expensive, and they like to set their alarm set points back in the control room in their own PLC. All right? Sales points. As I said, PCME is the manufacturer. Pentair/Goyen relabels them. Okay, so we are a direct drop-in replacement for all of the Goyen products, which is the EMP7 and the BBD6, which are obsolete, not supported. We have drop-in replacements for Dwyer. These are your competitors. So if anybody says, can you get me a Dwyer? Sure, you can get them a Dwyer, but you put more money in your pocket because of the margins available with these PCME Goyen units. So Dwyer's your competitor, Auburn is a competitor, Binmaster's a competitor, PCME technically is a competitor because we're buying them from Pioneer, not PCME, but we have the exact replacement, so it's a natural. It just wouldn't make too much noise about it, or PCME might yank that privilege away from Pioneer. B3 Systems used to purchase sensors from Goyen and PCME. Now I believe they've come out with their own technology, so they don't outsource the sensor. They manufacture their own, and their real claim to fame is in very hazardous scenarios where the particulates may be toxic. They have a calibration system that will do an automatic daily calibration. Okay. The important thing to remember from a sales standpoint is these are not really designed. This technology is not designed for quantitative measurement. This is designed where you develop a baseline, you set an alarm set point, and when it reaches that set point, you then send an alarm knowing that it's time to do maintenance. Okay. This is the basic sensor, of the electronics is here. There's a 1-inch British standard pipe thread fitting. Now, there are adapters you'll have to sell with this for that. Then there's an insulator, okay? That insulator isolates the probe from the electronics. If this shorts out, this equipment will tell you it has a short. Okay, you can also put an air purge on it to keep it from bridging across here and shorting out your signal. These rods come in different sizes, but really at the end of the day, it doesn't really matter how long it is, because what you're looking for is a representative on the clean side. So if it sees 2 particles or 100, you just adjust the sensitivity. Now, a huge selling point to our advantage, a lot of these guys don't have AC/DC technology, okay? And the advantage of that is that ours is looking for the electromagnetic field around particles. So if there's all these particles on the dirty side, right? Well, presumably this is on the clean side. Then your filter's here. If you get breakthrough in this filter, you get a tear in this filter and particles start coming through. We're just looking for the magnetic field of those particles. Our competitors, many of them, it has to physically strike this probe before it will respond to a negative effect or excess emissions. That has 2 advantages. One, we're more sensitive to something even in the vicinity, but more importantly, some of this particulates can build up on this probe. And if the competitor's probe is looking for that particle to strike it, but it already has a crusty film built on it, like the bugs on the front of your pickup truck in the summer, it will slowly degrade its sensitivity because the particles can't hit that probe. So, huge selling point, huge advantage. We got a price advantage. Definitely involve me if you get involved in a project, because like I said, a lot of these steel mills and all, they have hundreds of these monitors, okay, and hundreds of these valves. And we can sell kits for the valves. So now we're going to go to the actual demo. Okay guys, here's the demo, here's the case. This is the sensor probe, okay? And as I mentioned earlier, this is the electronics. This shield is for radiant heat to protect the electronics. Here's a grounding lug. This BPT pipe thread goes through the wall of the chamber or the collector. This is your insulator. Then this is the sensing probe, okay? This screws in and out for shipping purposes. Just be aware of that. That's in the case. Okay? Now, part of what makes this a great demo is, once this is cabled up, it's self-contained. It generates the power. And one of the highest selling points of this product, which didn't used to be available to the field, was the operator or the technician can adjust all the things they used to have to do in their PLC. So if you hit the right arrow, you'll see this is the programming screen, okay? And there's 6 different boxes. On the top, it's the sensitivity or the gain, which presently is at 5. Next box on the top in the middle is the low alarm, and that's programmable, how sensitive or how high the signal needs to go to trip the relay and set off an alarm. The next is, this is the alarm delay, okay? Because this is a hypersensitive piece of equipment, and if you don't put dampening on the alarm response and if you don't average out the raw signal of the 4 to 20, what you would see is every single spike. And those spikes can be generated by solar flares, fluorescent light ballasts, someone keying a radio in that vicinity, a static discharge from someone's clothing or in the bag house itself. So you don't want to trigger an alarm every time you get a massive spike. If you get a leak in the filter, it's going to go up and stay up. But some of those spikes are going to be twice as high as a broken filter signal. So if you just average it out, say, tell the electronics, I don't want to trip an alarm unless it goes above this point for this period of time, okay? And that way you can set your alarm threshold much lower so you don't set off hundreds of false high alarms. Now on the bottom row, again, there's more programming functions. This is taking 5-second averages, okay? So again, and that's taking those peaks off, because electronic false noise spike will just be milliseconds, not a minute or two. So that averaging also cleans up the signal. Now the middle bottom row is your high alarm, okay? This is when you have a cataclysmic failure. You know, the low alarm says, keep your eyes on this, something's going wrong. But the high alarm says, you must act now because there's something wrong, okay? You can also fine-tune your 4 to 20 milliamp output. And a lot of plants want to do this because they might have 5, 10, 15, 20 of these in the field. And every one of them is going to respond differently, okay? But they don't want Unit 1 to be running at 80% of range all the time, and Unit 4 be running at 5. So with your 4 to 20 and your gain or sensitivity, you can get multiple units in the same basic, running at the same basic range, okay? Now, I'm going to step back and let BJ take a picture of this display, or I'll put my mask on and I'll do some functions with the keypad. You still running, bud? Mm-hmm. So this is your program display, and these are the functions that I was speaking of. Sensitivity, low, high alarm, 10-second delay before you trigger an alarm relay, 5-second averaging to take the highs and the lows out, give you a flatter response. This is your high alarm. That's the OMG. It's time to get serious about fixing whatever's wrong. And this function, most people, that's a very new function for this technology, but that's your 4 to 20, calibrating your 4 to 20 signal output. Now if you hit the right arrow, this is your run screen. This green box with the check says, I see my sensor head over here, and we're communicating. All right? These are your alarm set points, and you can see them on the scale. if this thing gets a signal, there I just touched that with my hand, which is not necessary in most cases, but I had the sensitivity turned down. So if you want to get into the functions mode, hit the right arrow, then you're in functions. You can scroll through those functions if you want to change them, okay? Now, I've highlighted the sensitivity. If I hit the enter or return arrow, at this point I can hit the up and down arrow to fine tune my sensitivity. And you can see even when we're just standing in this room here, when I'm at 25, my signal's going higher and higher, and if I get my hand, my own electrochemical field will set off, triggering a relay alarm, okay? So you hit enter again, it'll flash red, and that says, okay, I've accepted the changes. Then if you hit the right arrow again, it takes you back to the program functions. If you hit it again, it takes you back to the run screen. So this is the screen that your average operator would be looking at under normal circumstances. It's a great tool, good for lunch and learns, impressive, fun to play with. It's pretty intuitive once you get the arrows and the returns going. I suggest you bring it in. If you play with it on your desk for an hour before you demo it, you'll be an expert.